that our panelists they have sent to me, and I will disclose who sent each question. So I invite you to have a look under your seats and to find something like this. So please have a look under your seats. Yes. I see that there is you can have a look over under this seat because there is nobody here. And you, for instance, yes, could you please come here to join me? Yeah. Who took it? Stefan or you, Stefan? Come here, please. Well, may I ask for your name?
Philippe Goujon from Valeo.
Okay. You?
Stefan de Vries from A+B.
Okay, good. So we have 3 questions, okay? And who wins will get this, okay? And you will see what what is the, okay? So the first question, you can see you can watch there the screen, and if you slide a little bit here, yeah, because otherwise the people cannot read it there. So the first question: how can the concept of multi-connectivity be useful for the CCAM services? Of course, compared to the simple connectivity. First option is improve accuracy of localization, for example, in channels, to ensure the integrity of participating entities. Third, enhance the reliability and latency of critical CITS message exchanges, or to enable better traffic management, for example, in case of an accident. As you came first, I let you to start.
I would say all of them.
Well, okay, you say all of them. Stefan?
Oh, it's very early in the morning for this kind of questions, huh?
So you can blame them afterwards, the person who launched the question.
Yeah, indeed, they look most of them look reasonable to me. So yeah, I would say 3 or 4 of them as well.
Okay, good. Well, actually, and then you have to ask to the person who launched the question, is to enhance the reliability and latency of critical CITS message exchanges. I mean, even if all of them can fit, this one seems that fits better, but our panelists will explain it later. Okay, good. So you are not very today in the morning, as you said. Okay. Second question: when the PDI, the physical and digital infrastructure, is supporting essential automated vehicles operation. First, in any occasion, so that the auto vehicles need always the PDI support, no matter in the situation that they are. Second, in specific occasions, so in this case, what they expect is to go beyond what their ODD, okay? I mean, what they have already, let's say, in their knowledge. Never, in no occasion, automatic vehicles are always able to operate without any PDI support. On last one, in the particular occasion when the automated vehicles run in high speeds. So, Stefan, your turn.
Okay, in this case, I would say 2.
And on my side, 1 and 2, more specifically 2, I would say also.
Okay, so well, in this case, yes, is the number 2. In the specific occasions, we are talking about essential automated vehicles operation. And again, this is something that our panelists at some point during their presentations, they will dig more into that. Last, and I'm afraid that this is very easy, at least for one of our 2 people that is here. Does the current European knowledge base on CCAM cover both connectivity and data sharing? 1, yes, it does not, as related projects are still ongoing. Second, even if it is covered, further information is expected from stakeholders and projects. Third, indeed, fully covered with the latest results of the related projects. And the last one, there is not any European knowledge base on CCAM, and we are working on it. So, your turn.
Number 3.
Okay. Stefan?
Yeah, 4, it's not. 4 is not the right answer, so I go for 2.
And actually, it's number 2, indeed. If even if it is covered, the very information expected from the stakeholders and projects, because it's actually a lively database that is being updated constantly there. So, okay, thank you very much. You are the winner. A big applause for both of them. You can go back to your places. Thank you very much. And well, indeed, this the three questions that you saw. These are actually topics, aspects that are going to be highlighted by our three panelists today. CCAM connectivity means one of the things, of course, what this is also three, not maybe the only ones, but these are important. Interoperability, we are talking about several elements that they have to interact between them so that they have to understand each other. This second aspect is cooperative systems and vehicles coexistence, and we are talking about in the same environment to have different kind of vehicles, for instance, not automated vehicles, semi-automated vehicles, or automated vehicles, so that they have to coexist and to interact between each other, and also to cooperate them in order to, well, to reach the common goal. And we are talking about also security and safety. For instance, in the first question, you saw the security, the CITS, the latency, the reliability. So this is one of the aspects that, well, that have to be also be considered while we are talking about the connectivity and also safety. How the people which is actually on board of the vehicles or the pedestrians, they feel that they are safe, and how the vehicles are driving there, or the elements ensures this safety. So for that, what I mentioned you before, we have our three panelists invited here. They are representing these three projects: PoDIUM, Augmenting, CCAM, and MobiDataLab. And well, now is the time for the first speaker, panelist, who is Mr. Dr. Vasilis Souras from PoDIUM. Could you please come here? A big applause for him, please. He's a computer engineer. He's holding a PhD on what? I don't recall it, the PhD.
On computer or future internet architectures, totally different things, but it's okay, thank you.
And actually, he's working in the National University of Athens, okay, in one of the research institutes, the Institute for Communication and Computer Systems, and you are leading one of the research groups of the ITS CCAM, okay, within the iSense research group, okay? Yes. So please, the floor is yours, and let's talking about the PoDIUM. Thank you.
Thank you very much. Thank you, Pedro, for the introduction, and mostly thank you for your help in running PoDIUM as the responsible project officer. And apologies from one of the three questions. It was also difficult for me this time in the morning to answer my own question. So once again, apologies. So I'm going to present you the status and the project and the overview of the project called PoDIUM. PoDIUM stands from PDI, where PDI is a physical and digital infrastructure, connectivity and cooperation enablers, building trust and sustainability for CCAM. This is one of the 2021 Cluster 5 projects, together with Augmented CCAM, the sister project. It is quite a large project. It has 26 partners from 8 different member states and a total budget of around 12 million. It is 36 months in duration. It started on the 1st of October. It's going to end by the end of September 2025, if there are no any delays, hopefully. And we are almost halfway there. We're on month 16 currently. As you can see in the map, you can see, let's say, 3 big clusters of partners, which are the 3 living labs that I'm going to give you some more details later on. One in Spain with a dual living lab, one in urban environment in Barcelona and one in the borders between Spain and France. One in Italy, also a dual living lab with one facility in the city of Turin and one in the Highway A22 using a very difficult environment, a tunnel close to the borders with Austria. And the third one is in the city of Ulm, where we have an urban living lab environment with the help of Nokia, Bosch, and the local university there. The scope of the project in nutshell is to enable connecting and cooperative automated mobility in real traffic conditions through very very demanding use cases in the 3D living labs that I just mentioned. In order to do that, we have advanced previous, let's say, technologies and previous architectures coming from old projects. That one of them was ICT for CART. with new features. One of them is the advanced multi-access edge computing. You might have heard it also as mobile edge computing, but the new term, I think, is multi-access computing, which are enablers of new use cases that have very strict requirements on delays and processing that has to take place at the edge of the network, as close as possible to the end users, to the VRUs, or to the vehicles, or to the road users overall. Another concept of the project is the data fusion of, in order to have enhanced environmental perception and enhanced environmental models of local generated data and distributed data, in order to have more accurate predictions and more accurate digital twins that can predict potential instances and, let's say, take some accurate measures in order to prevent them. Of course, in order to do that, we have extended in the project pretty much all the CITS messages, and we used and extended in some of them with new features. In one of them, actually, we have added a new quality metric where the issuer of a message decides and adds a quality metric on the message itself that can be used later on from the data fusion, let's say, digital twin, in order to take some decisions whether to include this information or use it with less, let's say, convenience. A third and very nice concept, another concept, is the software integrity, trust, and truthfulness of CCAM data. It's not directly coupled with cybersecurity. It's a matter of integrity and trust of software and hardware components that might not be malicious, that might have been not working properly. So it has to be periodically trusted and check that what they are sending is meaningful, or they have to be deactivated. One also great extra of this project is the integration of vulnerable road users, both in the decision of the traffic management decisions, but also as an end user that is also always connected through some handheld devices, their mobile phones, and can be issued to them messages in order to avoid, let's say, crossing a crossroad when an instance might occur, like an ambulance or, let's say, a fire brigade's vehicle has to cross this crossroad at the same time. In order to do that, as I said, we have demonstrated urban and highway use case in the 3 living labs, and 2 of them are dual. So the impact entities and processes, in order to cover all the physical and digital infrastructure, is on the physical part, the multi-access edge computing, wireless networking, different technologies of wireless networking, roadside units, onboard units, VRUs, and pretty much everything that lies on the road. On the digital part of the project, we have the traffic management center that we use a hybrid mode here. The traffic management center can run either at the edge when it's needed, for example, within the tunnel that I mentioned, or at the cloud where more information is available, more resources computational resources are also available, but the delay is not an issue, most like in that situation. The environmental perceptions, in order to have an enhanced environmental perception with information coming from the vehicles, from the VRUs, and from the infrastructure itself, digital twins, the new CITS messages, and the trust and truthfulness module. That's something that we have included in our projects. We might also see this kind of trust and truthfulness schemes in other projects covered from the CCAM partnership, like the CONNECT project. I'm not sure if it's going to be presented today, but it's one of those related projects. Since we are halfway the project, what we have done so far is to define the overall PoDIUM architecture. For some of you that you have a good memory, this might remind you of the architecture that we used also in the ICT4CAD project. It is, let's say, heritaged from this project, and we have extended with all those new features. One of them is the hybrid data management, meaning hybrid data management, we can move functionalities closer to the end users, let's say to the MEC, or higher to the hierarchy in the global data management, which is being executed in the cloud layer. As you can see, we have 3 layers here. One is the road level, the edge layer, and the cloud layer. Depending of which industry you are coming from, if you are coming from the telecom operators, probably you can consider that the edge and the cloud is the same entity. But I mean, in the CCAM world, it's a clear definition what is the edge and what is the cloud. The edge might not belong to the telecom operator that runs the 5G network, and so it is considered here as a different layer. At the road level system, you can see all the different entities coming from sensors processing units, where sensors are let's say, clever enough or intelligent enough to have connectivity to the rest of the architecture. You have the connected vehicles, you have the automated vehicles, you have, let's say, legacy vehicles that has no intelligence at all, so they have to be captured from the physical infrastructure sensors. And you have the RSUs, and you can see here different arrows, which means that there are totally different ways of communicating. We have wired communication in the PoDIUM project. We have cellular, capability. It is 5G, legacy 5G as we know it. We have 5G millimeter wave in one of the sites just to check this technology as well. We have different short-range communication, ad hoc communications. It is the ITSG5 as it is known, but we also have a new Wi-Fi scheme, the 60 gigahertz Wi-Fi, to check also how this technology can be combined with other technologies as well. This is just a view of the architecture. In PoDIUM, we have the architecture has been derived in 5 different views. Here is only the communication, let's say, view, but the different views besides the communication view, it's also the functional view, which is how the interaction of depicts the interaction of functions within the systems, the CITS messages, the traffic management center, etc., etc. We have the data flow and storage view, which is where the messages are being generated, where they are sent, where they have been stored, how they're being processed, and how they have been used by the digital twin. In PoDIUM, as I mentioned, we have used pretty much all the known CITS messages from CAM, CPM, MCM, VAM, a new message that is now popular for the vulnerable road users. The fourth view is the IT environment view, where it is pretty much dictates where each functionality is being executed, either at the edge or at the cloud, depending on the needs and, of course, the available resources, within the system. And last but not least is the software integrity and data truthfulness view, which is a new view using attestators in order to make sure that the integrity of the different components and also the truthfulness of the data using 2 different schemes in order to make sure that the data that are coming from a sensor are let's say, correct, or there is a malfunction there that has to be taken into consideration. The 3 living labs have similarities, of course, but one last word is that the PoDIUM architecture works as a blueprint for future CCAM, let's say, architecture for future CCAM projects. It doesn't mean that all sites have all the different components, but we have created a versatile architecture that can be, let's say, used in different situations. So, based on the capabilities of the network, based on the capabilities of the physical infrastructure, based on the needs of each use case, you can take a snapshot of each one of those views and you can build your own system. For example, in a use case, you might not need to have edge computing in order to run your traffic management. You can do that in the cloud. So you use these different, let's say, combinations of the different views in order to build your own system. The 3 living labs have a lot of common aspects, as it is in all, let's say, PoDIUM. It's the multi-access edge computing. It's both LTE and 5G coverage. Now, it's mainly 5G. It is the ITSG5 short-range communication, which is the automotive, let's say, Wi-Fi standard. All of them have connected automated vehicles. Actually, in each one of them, we have either a major or a smaller OEM, Mila in Spain, CRF, Stellantis in Italy, and the vehicles from Bosch, and of course the vehicles from University of Ulm in the German side. And of course we have VRUs either on a bike or pedestrians that are some of them are equipped with mobile devices, so that are part of the overall architecture. Below you can see some specifics of the different sites. The one in Germany, in Ulm, has as extra compared to the other living labs the 5G millimeter wave coverage, the 60 gigahertz Wi-Fi, and the multipath connectivity. We're executing there the idea of using more than one paths from the source to the destination, where the destination is might be in the cloud or at the edge. And the idea is not to use only the different, let's say, technologies like using both Wi-Fi and 5G, but also to use different paths using similar technologies in order to make a better scheduling of the packets towards the destination. And of course, we have RSUs and sensor processing units pretty much in all the sites. The Living Lab in Spain, as I mentioned at the beginning, we have a real urban traffic environment, a corridor in the center of city of Barcelona, where we're going to examine how the emergency vehicles and the emergency management center can be integrated in the traffic management center. It can safely, let's say, create a corridor for ambulances or for fire trucks to cross, let's say, the city and inform the connected vehicles or the VRUs in order to avoid any incidents. Also, there is this corridor with the connected automated shuttle at the borders of Spain and France, where we have mobile MEC servers on each side of the border, and the difficulty there and the challenge is to make them work seamless and collaborate in order to provide an accurate directions to the vehicles. Lastly, the Living Lab in Italy, we have also a complex urban intersection in the city of Turin, and the highway tunnel located, as I told you, in the Autostrada del Brennero, the highway that connects Italy and Austria. Here, the main focus is on the software integrity and the trust and truthfulness enhancements of the system, so that to make sure that whatever is coming to the system can be trusted and is coming from where it's supposed to be coming. I'm going to run a little bit now on the use cases. Now we are in the status of the project where we're going to develop and validate the use cases either at the real sites or at the lab environment. And towards the end of the project, we're going to move everything on the real sites and perform the demonstrations and the real evaluations. For example, in the city of Fulham, we have two scenarios where one lane is blocked, for example, and traffic in both directions has to share the single remaining lane. There we have two different scenarios, one with two connected autonomous vehicles driving in the opposite directions and have to, let's say, decide how to cross, let's say, this obstacle without the use of external sources, without the use of the physical infrastructure, without the sensors that are located at the crossroad, using only their own sensors and using their connectivity in order to exchange data. And the second scenario is with the use of the physical infrastructure, where also a VRU, a bicycle, is also part of the scenario and has no connectivity and has to be taken into consideration by the autonomous vehicles. Here is a view also of what I just mentioned in the city of Barcelona, the management of high priority vehicles and how to also include the VRU protection in it, so that at the crossroad where the fire truck is crossing, there's no incidents with the corresponding VRUs. Pretty much the same situation is taken into consideration in the third use case at the cross-border, in the Mediterranean cross-border corridor, where we have also two scenarios, one for the daily commuting across the borders and one with safety incidents across borders, where both traffic management centers in the two sites have to coordinate and manage the traffic within the corridor. Also, in a similar approach is taken also in the urban environment in the city of Turin, where here we have messages that are fused in the digital twin, and a fused CPM is generated when more information is available. And here we have extended the CPM with an object perception quality, where each entity, let's say, grades the quality of its perception, and so that the digital twin can take into consideration which data to give higher priority or which data are not useful, let's say, for the fusion process. Last but not least is the risk management in the 8-82 Brennero highway tunnel, where the situation there, I mean, the most difficult factor is that there is no service from the GPS, from the GNSS. So with the use of onboard units and RSUs, we count the number of vehicles that enter the tunnel. We count also what kind of the type of vehicles, if they are passengers, if they are heavy vehicles, if they are carrying any hazardous material, and the system and has a risk calculation process where at each instance decides how risky is the situation within the tunnel and sends IVIM and then messages from the platform so that to indicate to the autonomous vehicles to change, let's say, their automation level, decrease most likely their automation level or decrease the speed, and in order to make sure that the traffic within the tunnel is secured. I'm closing with this slide. I mean, the expected impact is obviously to provide an enhanced blueprint for CCAM service based on tight integrated physical and digital infrastructure, to enhance the quality and trust in extended data via truthfulness assurance mechanisms, because here the data coming from the vehicle sensors or the VRU sensors are important, a very important part of the whole process. And of course, to demonstrate the potential feasibility and sustainability of multi-connectivity and multiple communication together with new technologies like the 5G millimeter wave or the 60 gigahertz Wi-Fi scheme. And of course, I mean, the long-term impact should be to minimize the carbon and energy efficiency of transport and to increase, of course, the CCAM-related system and services. Now, the project, as I mentioned, is on month 16 out of the 36 months of its duration. The architecture has been clearly defined. The use cases have also been clearly defined and have been mapped to the blueprint of the architecture. And the next steps are to develop and implement the use cases and move forward with the demonstration on the real sites. Besides that, we have a close collaboration with the sister project Augmented CCAM, where we have already organized some joint workshops and participate in different events in order to share our architecture and probably PoDIUM to utilize their ODD taxonomy in order to be part of the traffic management. Of course, other activities has been done with other actions like the World Project, the Sea Roads, and PoDIUM most likely will be co-organizing an ITS World Congress SIS. Of course, we are also part of the FAME, not only because there are partners that participate in the FAME project, but it is also a nice opportunity to use FAME to reach a wider audience. I think I'm of time. Yeah, my last point is that yesterday there was a comment about synergies. What I want to mention is that, given that Dr. Jorge Pereira is also here, and also the projects coming from the different angles, the 5G, MOBIX, Croco, and those related projects, we have also coordinated as ICCS a new project from the SNSJU, which is called Envelope. It's dedicated for the CCAM vertical, something that shows that a nice and huge, let's say, cooperation starts happening between the two worlds, which was not very obvious, let's say, a few years ago. So, thank you very much.
Okay, thank you very much. An applause for him. And actually, I'm very happy to see that you mentioned the work that you do, the project is doing, based it on the previous results from other projects, for instance, ICT for car, which is actually the things that we expect, that we, let's say, you do not develop solutions that actually they're put within the cupboard, you know, and you are based on the work on that. Okay, so thank you very much. We will have afterwards time for the Q&A, co-moderated by Hamid as well. I would like to request the representative from Augmented CCAM project, Thierry, applause for him, please. He's a chemist, you know. I knew the other day, didn't know that, that you were a chemist and you have actually a PhD on chemistry. And you are a researcher on the environmental impacts on transport systems. It is very, very important. And actually, he's the Secretary General of the Association of the European National Road Research Centers, FEL. So the representative of Augmented CCAM, he will be also showing us information about how the project is related to the CCAM and connectivity and all the details and development that you have done so far. So please, the floor is yours. You can take this mic because the other one, it does not work. Thank you.
Yeah. Very good. Thank you. Good morning, everyone. And that's indeed a pleasure to be here today and to present this Augmented CCAM project that actually was funded in the same call as the PoDIUM one, with whom actually we are working extensively. We've had already 3 common meetings. The last one was not later than 2 weeks ago. So we are trying to let's say, move together. So this project actually started very much in some discussion within the FEARL network. We have a kind of flagship program called Forever Open Road with one pillar called Automated Road, and there this was, the question of supporting the deployment of CAVs was certainly on board, but also very much at the heart of AirTrack, and that's something which is great to promote this activity here, because indeed this AirTrack, let's say, roadmap was actually the base for the vision of 2050 challenges, where we would also try to respond to that with a very ambitious goal, I would say, of 100 real-time connectivity for all vehicles by 2050, which is almost tomorrow. So that's a lot of challenge to achieve within the very limited time frame, but we are trying to certainly work on it. And within the CCAM project, Augmented CCAM, sorry, we are trying to respond to part of it. So our key question, I would say, leading our project are the following one. We are certainly very much interested in defining the priority PDI requirements and adaptation for different mixed traffic application contexts, transport modes, and CCAM readiness. We are also working on some most cost-efficient technology path to exploit the existing and emerging PDI to support near-future CCAM, and certainly ensuring the safety and the efficiency of the transport network as a whole. We are not also trying to not look at some more challenging issue, or at least as equal challenging issues. I'm referring here to the concern that adopter may have, and also trying to look at the various governance and operational model that could support this, let's say, leveraging the, or let's say, removing the concern. And last but not least, we also try to provide some recommendation for no regret decision, having in mind that the budget that yesterday in the opening session, it was mentioned results, another keyword, and then money. And then I think the money is actually a big issue. So we are not working with more money. We are, let's say, optimizing the overall budget, and the investment that have to be done for, let's say, the support of CCAM is certainly very important. So we can't miss any right decision. And the timeline of the investment is also very important. We talk about 30 to 50 years for physical infrastructure investment, and certainly a bit half of it for the digital part. So in the augmented CCAM, we try to understand, to harmonize, to evaluate in an augmented manner the adapted and novel support concept of physical, digital, and communication infrastructure to advance its readiness for large-scale deployment of CCAM solutions for all. So we talk about implementation since yesterday. So this is really towards that goal that we are trying to work in the augmented CCAM project. This is a project with EU contribution of close to 9 million euro. 40 months. We started on the 1st September 2022. We will end on the 1st December 2025. We are 27 beneficiaries from 13 European countries, and this is actually a co-coordination between FEARL and CERT. Well, we have several objectives. I would maybe rank them, or let's say organize them in the following way. We first want to explore, to understand, to elaborate and extend the harmonize the PDI terminology, clustering and support level that will support the co-determining PDI requirements and adaptation. So that's one main objective. Secondly, we are trying to define an open sharing technology agnostic service operational framework and architecture for PDI enabled CCAM services and solutions, addressing the needs of all CCAM actors and modes. Thirdly, we are trying to develop an optimized and novel PDI support solution, aiming to enhance the AV's ODD and the whole transport system functional safety by deploying AI, but also big data, advanced techniques to leverage situational awareness, prediction, and actuation. We are also looking at evaluating the proposed PDI-based CCAM solutions. That's very important to us. By applying an augmented and multi-layer operational and evaluation framework that will deploy a vast spectrum of physical and virtual test beds supported by cross-source HD maps and microscopic and macroscopic traffic simulation activities. We are going to assess, and that's important towards the end of the project, the impact of the proposed PDI enhancement and novelties on CCAM ODD and CCAM operation, on functional and traffic safety, driving behavior, traffic efficiency, environmental footprint, service reliability, trust and security, considering the socioeconomic benefits and cost of all participating actors in short, medium, and long-term horizon. And last but not least, with all this and the assessment of the impact, we will try to come with a commonly agreed by all actors roadmap and recommendations towards an harmonized PDI of large-scale CCAM demonstration and deployment, as well as a risk-averse decision-making tool and methodologies for policy making and CCAM readiness infrastructure investments. So that's the main objective that we are trying to address in this augmented CCAM project. To make it happen, we have organized our, let's say, work into 4 main blocks. The first one is about developing this new PDI classification and support scheme for CCAM. The second one is to develop the technology agnostic service operational framework and architecture. The third one is defining the priority adaptations and the new optimized PDI support solutions for CCAM services. So some of the one that we mentioned earlier in the question. And lastly, to develop an augmented iterative implementation and validation plan to feed the impact assessment. So where are we now in the development? First of all, in regards to the first block, we are now at the stage that we have developed a new PDI classification and support scheme for CCAM. This actually integrates the different layers from level E to level A, so from the conventional sensing and planning infrastructure to the augmented and orchestral acting infrastructure for mixed fleet operation. For each layer, we have elaborated on the PI and DCI concrete elements. We have also identified in DCI the output and the map communication and digital enablers. All are initially well defined in a full PDI registry. We have considered different vehicle cohorts. We have identified the key restrictions for PDI support use. And we have referenced in details, all relevant schemas. So the one that you may also know for some of you, the ISAT Inframix, the shows, lanes, and so on. And we have included all different generations of CITS and TM services, as well as positioned the augmented CCAM in the anticipated solution for this scheme. So all of that are actually now recorded in, and I'm very happy to say that this is now released. So the deliverable that actually now present the new classification and the support scheme is ready. It's called Harmonized Registry and Integrated Multidimensional Classification of PDI Support Level. And it's actually a public document that you will be able soon to read. I don't know if it's yet approved, but that's another issue. Good. In link to this classification, we have also developed two tools. One dedicated for infrastructure support tools for CCAM, translating all the above semantics to assist decision makers, making context-specific priority investment in a handy way, enabling them for self-maintenance of augmented CCAM PDI support classification scheme. And another one which is about the PDI segmentation tool to assist road authorities with PDI readiness characterization. So we really want that this scheme revision, I would say, is used for let's say, practical operations. The second part that we are working on, it's about the technology agnostic service operational framework. So that's a bit similar to what was presented in the other project. And this operational framework really tried to reflect the existing and the emerging PDI and varying ways of its deployment. It certainly should be able to support all D1 and 1.5 CITS services and their evolution in day 2 and day 3 and so on, CCAM services. It is also enabling the granular traffic management strategies to road users caught in mixed traffic environment. And it's also here to support multi-actor cooperational models. And there, this is really close to be ready, so you will be able to get these results very soon. This is now part of a deliverable which is close to be submitted, entitled Open, Secure and Resilient Service Technology Agnostic Operational Framework and Architectures for CCAM-Ready Infrastructure. Well, the third pillar where we are working on now very actively is on defining PDI solutions for CCAM and to implement and to validate them. So this selection is actually 13. I don't know if it's a lucky number or not, but we hope that it will turn into a lucky number. So we have selected 13 different PDI-enabled solutions for CCAM. Well, assuming mixed fleet penetration, that's something obvious, aiming to leverage the safety and the cooperativeness of all CCAM users. Deploying certainly the existing, but also the emerging PDI, V2X, I2X technologies, and the AI and big data advanced learning and prediction techniques. It will address not only the passengers, but also the logistics, and it will integrate the different traffic contexts from road users, connected and not connected, focus levels, extending and, well, extended from network traffic management to critical safety, driving measures and maneuvers, and so on. Well, we really are stressing the fact that for each of these PDI solutions, we will really define in a meticulous way each of them, including the UML and the ODD-based scenarios. So this is a list of the PDI solutions that we are working on. You see that very, very diverse fun, from emergency vehicle approaching to road workers in the field, taking into account the non-equipped various use protection, optimized logistic operations of AVs, and so on. So they are really trying to tackle really different, let's say, use cases, if I may say it this way. For each of them, we aim to reach a high level of readiness. We are aiming at TRL 6 to 7. And I'm happy to say that the first description of these PDI solutions is now ready. So you see that the work, though the project has not started for a very long time, we've been very active from the beginning. So we are happy to say that this is now released, and you have the list now, the description of each of the use case, which is a public document as well. Maybe something to add about that. We are now also defining the multi-layer and iterative validation in physical and virtual test bed. So we want to assess each of these PDI solution using a mix between the real traffic and certainly the, let's say, the augmented reality that we want to put on it, if I say it this way. So the test will really be very wide, from 20 kilometers to 130. Not sure yet that we can go up to 130, but this is the aim to do that in France, where it's authorized. And so we will use 9 CAV demonstrators, certainly 10 more connected vehicles. And we will use the benefit of the 3 countries that we have chosen for that, France, Latvia, and Spain, to have very various different weather conditions, from sunny, certainly, in Latvia to snowy in Spain, but we'll see that. And then, well, we will also work in confined area and living labs. Some of them will be in urban and more rural environment. Other one will be in highway operation, in open traffic. And then also one thing important, we will also want to make some tests with different national operators as well. So the test, in a way, or the validation will run into 7 loops. So normally at the end, we should get something very consistent in our project. Toward the end of the project, we also want to assess the impact of our solutions. This is very important to measure if the solutions provide positive impact or not. Well, when we talk about impact, we talk about impact, certainly direct one at the vehicle level, but also at the network level or beyond the transport system. And this is also something very important, though we are working in a very, let's say, specific manner. We have to see what are the effect of these solutions in the overall traffic and certainly beyond that. So we will use certainly as baseline the situation as we have now, and then we will compare to the situation, the baseline, every of our PDI solutions, and we will be able to assess if there are, let's say, positive impact or not. And based on that, the third step will be to let's say, write some recommendation on PDI justified investment. So to do the assessment, we will use a set of key performance indicators. We have now selected 37 of them in various areas, from infrastructure functional safety, quality of service, trust and security of CCAM, logistics for CCAM, and so on. These ones are now ready. Doesn't mean that they may not be improved a bit, but they are ready, and I'm happy to say for that it's also released. It's a public document, so I hope it will be able to be also useful for everyone to work later on that. So against this document, we will be able to assess the promised impact that we had in the grant agreement. Well, we'll see afterwards if we're right or not in our justifications. But normally, we hope that this will be, say, with large positive impact, 50% reduction of accident, and very positive impact also in the reduction of the delay time, the energy resources consumption, and so on. And last but not least, we will also try, as at the end of the project, to boost in a way the deployment of some of the services, the business model as well, the endorsement of the classification, and then, hopefully getting some proactive decision on CCAM planning and PDI investment towards no regret measures. With that, I can see that I have to stop, so I stop, and I thank you very much.
Thank you. A big applause for him, please. Thank you very much, Thierry. I'm very impressed to see the 13 use cases to cover almost all the scenarios that you mentioned in the to demonstrate the PDI solutions. I would like now to ask the last panelist, Laura, Mrs. Laura Babino. Babio, Mrs. Laura Babio. She will be introducing information about the project MobiDataLab, and actually the project is recently ended, the 31st of January, I mean just 8-9 days ago. You are a civil engineer, okay, and you hold a master's degree in transportation systems, and actually you are working currently at Polis, okay, leading the cluster of mobility and traffic efficiency. And on top of that, you are from Galicia. I really love this area, this Spanish area. So yes, you can actually now, to use the mic because it does not work. Perfect. And you can introduce the information about MobiDataLab. 15 minutes sharp. Thank you very much.
Thank you, Pedro.
Even less if possible. Thank you.
Yes, I will try to do it in less time so that we can all have some Q&A, and also because these presentations were great but very, very dense. So I hope that you can still that I can keep your focus. And you should all visit Galicia. Thank you for mentioning that, which is in Spain, a lovely region. I'm super happy today to bring you MobiDataLab, which, as Pedro said, we just finished literally last week. We are not supposed to have favorite projects, but this was one of my favorite projects, which is surprising considering that when I first read the grant agreement, I probably didn't understand like a third of the words that appear there. So we've come a long way. I have today then some very nice results to present. First, what is MobiDataLab? MobiDataLab started 3 years ago. We weren't a big project. As you can see, we had 10 partners in our consortium. Even though we were a small consortium, we had still a representation of different stakeholders from the industry, from the research associations like Polis and also F6S. We had approximately a bit less than 3 million funding. And the main objective of MobiDataLab was really to foster the sharing of data, of mobility data, amongst different stakeholders in Europe. So we were not really a CCAM project. I would say that it was more an enabler, data sharing. So we're a bit of the odd project in this session, but still, I think very relevant to this session and to others, because already yesterday, that's what I was hearing, data sharing as one of the challenges, as one of the barriers. So this is really what we were trying to solve, not really solve, or at least to help solve. And how? Well, first, by developing a prototype of a cloud solution that aimed at easing this sharing of data, but also trying to understand what the different stakeholders' needs were, their requirements, and try to also see how this could, we could collect this advice, analyze it, and use it to support public authorities. And then finally, what we wanted to do is also to see how we could combine the different stakeholders in these innovation sessions where we tried the products, the transport cloud, in a use case based, in trying to solve real mobility problems using real data sets that existed. So that was just the basis. These objectives we tried to solve with the MobiDataLab approach, which 3 pillars. The first was building the open knowledge base, trying to understand what are the mechanisms needed to enhance data sharing in the transport sector, but also giving a bit of a know-how on how to improve the findability, the accessibility, the interoperability, and the reusability of mobility data. The second pillar was building or defining this transport cloud prototype, so providing a scalable cloud solution for the sharing of mobility data, and also to try to showcase the most effective means to access and exchange the mobility data, to processes, to enrich it, etc. And then finally, we had the living and virtual labs, where we gather the different representatives from the data users, but also the data providers, and try to conduct these innovation sessions to co-create, explore, experiment, and using data as a tool. So that was, in a nutshell, MobiDataLab. Let me go immediately into the results. First is the open knowledge base. I really want to encourage anyone that wants to know more about data sharing, that feels that maybe it's not up to date in standards, which are also something that comes up in every discussion and conversation that I'm in, but also about cloud solutions. One result that I think it's really, really good is the work done in the legal and governance, CAU11 analyzing the different legislation at the EU level on data, GDPR, but also the ITS directive, the RTTI, MNTIS. And this was a document that was already praised by the Commission itself, because it's a complicated, complex word, the data legislation. So here, if you really want to know more, you can find all of this information in our website, which is mobidatalab.eu, very easy. And this was really used and served to build the knowledge within the consortium, but also to help develop and define the other results. One of them was the transport cloud prototype. So here you can see the different elements. I'm not going to go too much into detail here, because I highlight the main elements in the coming slides. Just to say that the architecture, really what was the main goal was how to make data fair, so findable, accessible, reusable, and interoperable. And these, all the elements that include, are responding to this objective. The architecture that was defined covers this cloud federation, but also the governance and the use case requirements, and it's based on using established standards and elements that already existed. So going a bit into detail into the different elements. First of all, the requirements were based on use cases that were defined together with cities. You probably saw that cities, public authorities, were not part of the consortium, but they were engaged with through police mainly. We came up with 2 different set of use cases, one that we call the one for operations, from emission reporting, analytics, journey planning, and the other one that was more for research, looking at inclusive transport, sustainable transport, and link open data. And these use cases help us define the functions of our transport cloud. Then into the elements of the transport cloud itself. So MobiDataLab didn't host any data. The data remained with their owners, but we did create this metadata catalog where we harvested the data, where referenced it, and then we described it. We did a lot of work in describing this data and allowing translation so that the data was more findable, which was one of our objectives. And this catalog is hosted on CCAM and on GeoNetwork, and it can now continue to be built up. Then we have as well a service catalog, which was also open source based catalog to make easier the access, but especially the usage of the data. Here we included the access to the data sets through different APIs, but also we had different services from the ones from the own consortium, like the HERE developer suite or the Navicio suite, but also other services that we included. And this is again open source, and it can be continue to be built on. Like now we can, after the project, other services can be integrated by anyone. We are going to continue reviewing them. Quality is not that anyone can post anything, but it's open, I meant, for collaboration. Then we also developed some data processors to improve the reusability of data. This was done maybe by mainly by the CNR. We have on the one hand one for the semantic enrichment, which allows then the data to be enriched in different aspects. If you have a trip, you can have it include more stops, more information about the stops, the weather, the traffic events, points of interest. And then we also have the geographical enrichment of data, which allows that precisely to add additional geographical attributes to the data. And then finally, very, very relevant, as we also comes up, is the anonymization technique, so that we can process personal data, so that users can process personal data. Different techniques were developed and included in the cloud, and this was done by the URB, the University of Rovira i Virgili in Catalonia, who are experts on this data anonymization and privacy. And then finally, what we did to test all of this transport cloud, we wanted data users to use our services and the data that we harvested. We had 3 what we called our living labs that were done using a virtual lab. The virtual lab was a platform that was developed by one of the partners, Aethon, which allows us to put together the innovators, those startups, those users that want to use the data to develop a services with the cities who would pose there or who would include there a challenge, a problem that they wanted to solve using a specific data that then the innovators could access to and propose solutions all in this platform in the virtual lab. We had 3 events last year. The first one in May in Berlin, which was a datathon, which mainly aimed, it was a short event, 1 day and a half, and it mainly aimed at exploring data analysis with visualization and trying to get new results, new outcomes. The hackathon, it happened in Paris in September, and here we wanted to continue on the results from the datathon, and we asked participants to work a bit more to elaborate the prototype, the service, the idea, to plan it, to see what the results that they get from the data, how could they fit a new service, a new app, a new tool. And then finally, the Codagon was, you never heard about this, that's normal. It was a term coined within the project, which was a 3-week online event that concluded in a physical award ceremony. And since it was 3 weeks long, we expected also participants to give us something a bit more developed, something that was already at least maybe a functional prototype, whereas in the hackathon was just a plan that we needed. So in total, we had more than 200 registrations. We did not end up having all of these registrations submit solutions in the end, but I think that it was already good that we at least engage with this amount of users, and we also collaborated with NAPCOR for the national access points, with different transport organization authorities, sorry. And in the end, we really got a lot of very good feedback from the innovators themselves that had an opportunity to discover data, but also from the cities who received a lot of new ideas that came from the innovators themselves just by providing a few data that was published in any case. So to finalize then, that was just a really quick presentation, but I'm gonna give you later an opportunity for you to go a bit deeper if you wish. The project was already very impactful throughout its lifetime, meaning that we collaborated with many stakeholders, and we know that our results fed other projects and that have been useful already for different initiatives. Looking at the 3 main objectives, first on the consolidation of knowledge, really the knowledge base that we created on data sharing, it's a state of the art. It's really good. Now we need to see how do we continue disseminating all of this good work that was done, but we had more than 300 data sources referenced in our transport cloud, and we documented more than 150 initiatives. Then for the improvement of the service and the products, we did involve the transport stakeholders. In the end, it was more than 20 that actually submitted solutions of improved services and products. And we also evaluated more than 40 products related to mobility data share, the impact on sustainability and other attributes. And then finally, about fostering the data sharing culture, I think this is something that we definitely achieve, and we know that we are going to continue working on it, and the MobiDataLab will continue to be relevant. We, as I said, gathered information for more than 250 data providers and consumers. We collected feedbacks from more than 100, and in the end we managed to build a community here of more than 150, but if we count other networks and other channels, we had more than 700 people that were interested in MobiDataLab. And then it didn't start like this, but I think that as the project advanced, and then there were new news coming also from the European mobility data space, we realized that this project was also a precursor of the European mobility data space, and we are now working very closely so that the results from MobiDataLab continue. We have several partners that are a part of the new deployment project for the European mobility data space, like Police, but also CAU11, to ensure that all the good work that we did analyzing the data sharing culture, the impacts, the governance, the legal, continues to feed other projects. And we know that we are going to ensure this because, as I said, the consortium has been really wonderful, and we are all committed to continue the exploitation of the results even beyond the project. We are going to continue meeting and to continue working together, and we establish very good cooperations with other projects, even more than the ones that are here, and also through our advisory board, as I said, to make sure that our results continue feeding other projects, other results, and that we continue building on them. And then finally, this was really a very short presentation, so if you want to know more about the transport cloud, about the anonymization techniques, about the legal analysis that was done, then I invite you all to register to our final webinar, which will be at the end of this month on February 28th, only for an hour and a half. And there you will have also all the partners that developed the different elements to be able also to explain more in detail. Also, if you're looking for more technical details, they will be able to help you. And that's it for me.
Thank you very much, Laura. Big applause for her, please. Actually, yeah, you can leave it here. Yes, please. Actually, this is one important part that you mentioned it before, because even if it is not a CCAM project, but we are talking about connectivity, we are talking about PDI, but how all this information can be shared, so you can provide this solution. Well, I mean, now we proceed to go for the Q&A section. Before that, I proceed just to disclose the who launched which question. The question regarding to connectivity was launched by Vasilis, the representative of PoDIUM, so that if you can actually to request further information, it was a little bit discussion about the possible options you can ask. The second, which is related to the PDI support, it was launched by Thierry. And the third one, it was launched by Laura, the one related to the EUCAM, CCAM knowledge. So, well, thank you very much. I hand over now the flow to Hamid so that you can proceed with the Q&A. Thank you very much.
Thank you. Applause for Pedro. Fantastic job. I would love to say that we have plenty of time for discussions. We don't. So concrete questions, very straightforward questions after I presented myself. My name is Hamid Zarghampour. I work as Chief Strategist at the Swedish Transport Administration, and I'm also a CCAM Vice Chairman. I'm newly substituted Serge Van Dam. He presented himself yesterday. Fantastic projects, very nice. I have one question, but before that, please raise your hand if you want to raise questions to our panelists here. Yes? Yes, please. Thank you, Marzena. I learned that I don't give the mic to people yesterday. See?
Thanks, you're running again. Good morning. I'm Carla Jakeman from TRL and Smart Mobility Living Lab in London. Particularly to Vasilis and to Laura, I am interested to find out, now the UK are associated country, hooray! Not that I'm happy or anything. Can you please let me know if there is a mechanism for other living labs to maybe get involved in your projects to either share or learn from the projects you're doing?
Is it this one? So our project, as I said, has officially ended last week, but I know that all the partners are interested in continue working on it. So if you want to be in touch, you want to learn more about what we did, about the Living Labs, just now find me and I will give you my email and I will put you in contact with anyone. But just so you know that the project has ended. So this also limits a bit what we can do.
Fantastic. Even more data sharing. Data sharing is a big, big, big issue all around Europe. Please. I keep the mic like this. No, I don't give it to you.
Okay. Hello, Pierre Chewan from a PTO dedicated on AV in France. I have a question to Vasilis and Thierry regarding the data and the exchange of data. Did you tackle the question of responsibility when you send information to a vehicle and this information could be false or not? For example, the vehicle received an information that everything is okay, and when he's on 100 kilometers per hour, he was based on the PDI information, and then there's something on the road and there's an accident. So did you tackle this legal responsibility?
Very good question. Actually, liability issues. Who is doing what in this system?
Yes, let me start. I mean, not reliability per se. We call it, let's say, we have this last view of the infrastructure, which is called software integrity and data truthfulness. So probably truthfulness can be related to reliability. So the idea here is, one thing is to make sure that you are who you are when you say you can continue with 100 kilometers per hour. This is a distributed scheme based on attestators that periodically check if the OBUs and RSUs are those who are supposed to be. And we have, we're also investigating the thing of data truthfulness with two mechanisms, one with redundancy of data using more than one sensor. So if one sensor says that the road is not occupied and the three more says that the road has an obstacle, then we just deactivate the sensor. This is one part. Or with statistical methods where when we receive data that doesn't seem to be matching to previous historical data or data coming from other sources, we can also exclude them from this point of view. But I guess at the end it is the vehicles who decide if they're going to follow the rule, but this is pretty much what we are trying to investigate in PoDIUM at least.
Mm-hmm. Well, I would say it's very similar to what we do in Augmented CCAM, so extremely similar. So there is no legal per se work, but exactly what was mentioned earlier. What I could maybe add is in the presentation I mentioned zero cyber threat and data breaches. Actually, we are now thinking that's not maybe the right way of promising as impact, but more working on, let's say, promising resilience to this, because
exactly.
Yeah, I mean, this was to get the project funded, and then we can see.
Yes, that's it. There are several components in this discussion, actually. The quality of data, the liability issues, and what is the purpose of using this data, like redundant system, but still the vehicle itself is responsible. This is what you are saying. But you are working with the quality. Exactly. Yeah. Right? You are satisfied?
I mean, the most important thing is that it's not only the malicious users, it's also that something that happens to malfunction. A sensor has some issues and just send crazy data. So it is important to make sure.
So there are a lot of crazy data also. So yes. If there are no questions, I have one question to Terry. This is impressive how much we can do. And also you, actually, Vasily, we are adding a lot of things into a system, road infrastructure. We are putting a lot of intelligence in the system itself. And one very big concern is that whether or not we are actually recreating a kind of complex system that when something fails, nothing works. And this is actually, we have a similar system called the railway. When something doesn't work, everything is stopped. How do you think? Can you elaborate on that?
I mean, as we say in the consortium and in Envelope as well, we're trying, to make the stochastic system, which is the traffic, or probably a chaotic system as you move closer to Mediterranean, into a more deterministic approach. But, this is happening, adding more and more data, more and more complexity. Okay, the systems have been evolved. The 5G, let's say, system has been evolved, so there are solutions that can handle this kind of data, this amount of data. There are redundancy schemes that can also support towards the direction. There's multi-connectivity. They can move, let's say, the functionalities across the architecture from the cloud to the edge. But still, you cannot make sure 100% that the system will perform as it is. Something might go wrong, and a vehicle can brake in the middle of the highway with any obstacles in front of them, and a crash can happen. But the idea is to minimize these risks and make it work, I guess, better than manual driving or similar situations without the corresponding data.
Yeah.
Yes, please.
Maybe if I had things there, I would tend to say that this is not really maybe the issue of the complexity. Probably we can manage it, and I think there are many, many complex systems working very well. Probably the two things related to that is then the dependence on it. And when we take, for instance, this mobile phone, for instance, Google Map or whatever, now many people don't know where they are going. They just follow the indication. And that may be more this that we could possibly, let's say, the dependence. And if something, well, there is not really even the problem of, let's say, dangerous, but more if the system stops for a while, then we are all disturbed and perturbated. That may be I would say, probably the challenge. If I had also one more thing, there was a project in the past called Coexist, and this one was also looking at the, let's say, the transition phase. And I remember in this project that in the transition phase, we were moving from, let's say, the situation now to a hell situation before we can get indeed all the benefit of this complex system performance. So I think this is the second thing that, this second observation, this health path in a way that we will have to face, and traffic authorities or traffic organizations like yours will be in charge of this transition with all the challenges. And at the beginning, it will probably be difficult to justify that we need to go there when it will be, more chaotic on the road at the beginning, maybe. But this is at least what we could see in that project. And yeah, that's another challenge to face, I guess.
More questions? Yes.
Yes, hello, good morning. My name is Sven Janssen from TNO. I'm involved in the MODI project, and there we look at coordination of automated vehicles, which is similar to the orchestration that you mentioned in Augmented CCAM. I'm wondering which of the authorities do you envision for orchestrating the traffic? So what are the responsibilities and which stakeholders are involved to do this orchestration?
Very good question.
Yes.
Yes.
So at the moment we are involving, I would say, everyone, but certainly the owner and operators of the infrastructure. And this is not yet defined who will be the final orchestra, let's say, chief of orchestra. But in the orchestra there will be many players, that's for sure. And the chief is to be defined along the months, and I don't think it will be even maybe totally fixed at the end of the project. But certainly the infrastructure owners will have a huge play there. Yes, that's what I can say at least. Yeah. Sorry. Yeah.
And you've worked with these
Yes.
owners?
Yes.
Yeah?
Yeah.
And can you give the perspective? Do you say something about it? What they say?
Well, at the
Do
moment...
they have money to invest in everything you say?
So we have not been yet, so this is another, this pillar of activities has only started, so it's hard to tell a bit more, but so talking about money, really this has not been part of the current discussion, but this will come because, you know, as you can see, we need to go for recommendation toward the end of the project, and recommendation goes with money. I mean, it cannot be in the air, otherwise there is no implementation. And as Pedro mentioned at the beginning, otherwise that's a project that we will just make, you know, put in the cupboard. So this is not what we want. So yes, yeah.
Good. More questions? Sounds looks that you're satisfied, are you? The thing is that, yeah. Do you want to say something now? The thing is that this is very interesting, actually, that there are so many ideas, technological advancement that we can get, that people have advantage of using it. Somebody has to pay, actually, for the investments and investments. You know, I have been working with authorities all around the world, actually. I have never, ever seen a road authority claiming that they have so much of money, they don't know what to do with it, and they want to invest in new things. And this is not really happening. And something we have to show, we have to justify the investments we are doing in everything, every day. Maintenance works, the investment, new investment, all of it. The priorities between enforcing a bridge or investing in digital roadside units, things like that. So there are questions that we have to justify in comparison to the benefits. And if we can show that there are benefits, then we are actually speaking partner to authorities. This is my experience. Have been working with authorities for many years. So these discussions need to be also addressed in projects like this. I believe so. Okay, with that, we are on time, actually. We start 10 minutes earlier the next session to have time for discussions at the end. Thank you so much for participating. A big applause to everybody here. Thank you.
Okay, I think we need to start. So good morning, everyone. For those that don't know me, my name is Jorge Pereira from DG CNECT. DG CNECT is Communication Networks, Content and Technologies, DG. It's really my pleasure to be here at this conference, showcasing the results of the road transport projects. The Commission has, DG CNECT has invested 150 million euros in the past framework program in the area of 5G for connected and automated mobility, addressing mainly the big challenge of continuity of service when crossing borders. The aim is to have pan-European services without interruption. Without this, it's not possible to have automated vehicles, which is a long-term goal of this whole research. So without further ado, I will pass the floor to the three projects that have been looking into 5G for connected automated mobility for cross-border corridors. This is the first set of projects, the first call of 5G for connected automated mobility, with a focus only on roads. We had a subsequent call, which brought already rail and namely waterways into the picture, and we have even now a project looking into coastal maritime automation. So without further ado, let me call to the floor Maciek from 5G Kroku. He was the deputy technical manager, but in fact the person that was in charge of the actual trials at the border between Luxembourg, Germany and France. So a very, very intensive project in this area. Please, Maciek.
Yeah, thank you very much, George. Yeah, so hello everyone, and then welcome to once more presenting this project, but happy to be here in this context with the broad community listening. Yeah, so as mentioned, my name is Maciek. I'm with Ericsson Research, located in Germany, Aachen, not far from here, yeah, cross-border region, and where I by now am leading a research unit. So let's start with the overall project presentation. So it was already mentioned, the main area where the project was executed, Germany, France, and Luxembourg, where we had corresponding ecosystem partners from road traffic authorities, policymakers, and mobile network operators on board from each country, but additionally also from Spain, especially CTTC, who was coordinator. Everyone who know him, best wishes from Miguel, who was our coordinator, who was not able to come here today, so that's why I'm here on his behalf. And then partners from, well, Sweden, of course, Ericsson, Italy, and Greece. So original project duration, 36 months, and you can see by the dates, we hit exactly into COVID, yeah, so a pandemic is really not a good time to do a cross-border project, but somehow we managed with a little bit of 8 months of prolongation. So, yeah, what did we do? 4 crosses, yeah? So the key intention also mentioned by the call was cross-border or cross-country border service continuity. This naturally comes with a network operator challenge, yeah, so as of today, countries have their own operators. Even if they belong to big operator groups, each and every country have their own telco operator or set of operators. Well, there's also different telco equipment vendors, and of course, luckily, there is also many different car brands out there. So this is the 4 cross challenges we addressed in the project. The projects were intended for autonomous driving, so we came up with 3 use cases that all relate or are part of autonomous driving: teleoperated driving, high-definition map generation, distribution, and anticipated cooperated collision avoidance, yeah, hazard warnings. But all those 3 use cases, more or less, also have a role for human-driven and or driving assistance systems. We evaluated all these use cases in large-scale campaigns. There were also small-scale test sites, but here I will focus on the large scale. And the technologies that were evaluated is, of course, 5G new radio, but also mobile edge computing, end-to-end quality of service and network slicing, quality of service prediction, and precise positioning. At the beginning of the project, we were a little bit surprised why we were so much pushed from the start into also looking at business deployment aspects. But yeah, after a few months, we realized that there is also the Connecting Europe Facility digital program coming. So it became obvious that we get the unique chance to go from an innovation project into then deployment funding. So, results. So this is the 2 test sites. So it ended up to be 2 distinct sites, so we didn't close the full circle as we wanted to really focus on the border. So we had 5 sites in Luxembourg and 1 in Germany, and we had 8 sites in France and 2 in Germany. But as the focus became more and more the cross-border, it was typically the cells right at the border where most of the trials were conducted. So I was one of the first people who got to do the trials, yeah, being someone who also lives close by to that border and getting special permission during COVID times. I was not allowed to leave the car, but I was allowed to conduct the trials. I started initially on the highway overpass, which you see in this picture. Yeah, so this is the bridge between Schengen in Luxembourg and Perl. And one of the first things, so before that we did many 5G trials on closed proving grounds with controlled speed, yeah, having everything fixed. And we realized, whoa, not so easy on a public road, yeah, to do fixed speed trials and things like that. So many trials were also done in the vineyard. You see here right off the motorway. Yeah, radio waves don't care for politics. Yeah, so the handover was actually happening on the German side in the vineyard. Without going into details, I can tell you that it is technically feasible that a radio handover between the cells of two countries happens as seamlessly as within one country. So this is then the solution of inter-PLMN handover, and that's feasible and preferred. Yeah, so typically today networks have around 100 milliseconds service interruption. This is something which you will typically not perceive. Yeah, it is maybe 100 can sound like a lot, but it is a rare event. It's not like we're going back and forward at the border all the time. There is still two intermediate solutions possible, but I would like to point out the result on the very blue. This is my situation every morning. Well, not today, yeah, so I live in Belgium and here I am in Belgium, but typically every morning I start in Belgium where I live and I travel to Germany when I work. I often like to start my call at home and then I get it interrupted when I cross the border. And sometimes I have to go all the way to the first parking on the German side, stop my car, put my phone into flight mode and back, things like that. So whatever solution we come across will be better than what we are facing today. Another very interesting result to see that out in the field. So among the most important key performance indicators for mobile network communication is the spectral efficiency. So this tells me how much throughput, yeah, how many megabit or gigabit per second do I get out of each megahertz of spectrum. Yeah, if you follow how much money is paid for spectrum leases, you can imagine how valuable that is. So we did a direct comparison of the maximum throughput we get with 4G and the maximum throughput we get with 5G. Yeah, so luckily in so-called 5G non-standalone mode, you still have both systems there. And for the downlink, yeah, so communication towards the vehicle, we see that the efficiency has doubled. Yeah, so this roughly means if you have 100 megahertz of spectrum, you get 1 gigabit per second out of it. Not shown here in the graph, but for the uplink, it's still a remarkable 50% of performance gain compared to 4G. So we are using our precious radio spectrum much, much more efficient. If we look at the use cases, yeah, so the HD maps and the teleoperated driving, those are throughput-heavy use cases. So we can assure that they get the throughput they require. Hazard warning, yeah, so the anticipated cooperative collision avoidance use case. There we want to serve many, many vehicles, each generating small amounts of data, but in total still a lot. So there we are capable of handling many, many more vehicles than it would have been possible with 4G. Coming to our contributions in standardization. So this was also quite a nice challenge. So as an innovation project, a 5G PPP Phase 3 project, we were supposed and expected to bring to the curb very mature technology. At the same time, we were also supposed to make a difference in standardization. So we kind of struggled hard at the beginning, but still, I mean, things go on in 3GPP being the major cellular network standardization. So there, at least companies active there contributed to 30 contributions related to the technologies which we tried out in the project. We had few contributions in ETSI context, so there we must really say, well, now a phase 2 has started, but back then CITS phase 1 was closed. But especially then, yeah, so not talking about standardization, but industry associations that try to make the next step towards commercialization, we have then 36, or during the project time when we counted 36 contributions to the 5G Automotive Association on the use cases and also in technology domains. Furthermore, the fifth cross. So there's also the cross-project perspective. Yeah, so we mentioned we were in total 3 ICT 18 projects, and there's also the 4 ICT 53 projects going on, and now also the first round of CEF2 5G corridor projects. So first of all, we each carried out individual deployment studies. Yeah, somewhere we figured out, because there will be also the CEF funding, and we are doing preparation work for that. But then we also all together compiled it into a joint deployment study of the 3 projects together. And nice overview, so I had to go a little bit fast through some of the points, but all of the points and few more, especially the other technology components, you can all find in our joint white paper we have recently published as one of our last dissemination attempts. Okay, so expected impact of what we were doing. Let me start from the bottom. Clean mobility, and we have to think a little bit around the corner here. Yeah? So right now, I mean, it's difficult to claim that connectivity is a must-have for autonomous driving. Yeah? So that's where Tesla proves us wrong. Yeah? So they got quite far with autonomous driving without connectivity playing an essential role there. But, yeah, I mean, they anyway have done fun in different legislations, what is allowed and not allowed. Another example which I follow a lot is San Francisco. Yeah, so maybe they thought, General Motors, Cruise, and Waymo, that they can get quite far with only fulfilling legal communication obligations. But if we think what has happened, so we have thought of emergency vehicle warnings, fire brigades, years, if not decades before. So this would have made the life of the autonomous drive, of the robotaxis in San Francisco much easier. And if you think about the most recent accident, that would have been an example, or where even more remote supervision and teleoperated driving would have hopefully helped to especially mitigate this PR disaster. So this shows the importance of communication to really ramp up autonomous driving without all the pain we currently see ongoing in the pilots. And from an autonomous vehicle, we can expect that the algorithms are designed in a way that they will minimize power drain in a way that a human would never be capable of doing. So much better control loops. And the other thing is, just like as I came by train here, I really don't care about plus minus 20% travel time once I'm not the one who has to concentrate on driving. So in a human-driven vehicle, we can trade energy efficiency for speed. So we can go slower, we can take different paths for the sake of consuming less energy. So this is the main benefit I would like to stress here. So communication indirectly supporting the uptake of autonomous driving. But nevertheless, there's also some other factors mentioned here. The prerequisite for all that is coverage. So if there is no network, there is no connectivity, and you can forget all what I said. And this includes the country border. So what we have at the moment are hundreds of kilometers of white spaces across the European Union because of the technical challenges I mentioned earlier. So with my phone, if my car modem is busy finding the right network to use, I have no connectivity services in that time. And the other thing, of course, we need the technology to reach the vehicle. And there we are, of course, also dealing with the different innovation cycles between telecommunication and automotive industry, especially when it comes to personal vehicles. So public transport and fleet, commercial vehicles, there's still more retrofitting going on than in personal vehicles. Okay. Mentioned it a few times, coming to key takeaways or key findings we see when we think about the CEF deployment funding. So in the call document, you can already read that the authors, that the commission understand there is a certain chicken and egg problem. So it allows really to make it easier for telco and automotive industry to try out, to figure out where are the use cases of key societal and or financial or business benefit. So this eases the financial pressure. Nevertheless, it was totally understandable for us as innovation project that we had to exploit the limit, that we had to go for very demanding use cases. And by that, yeah, so if you can manage the most demanding ones, you can also manage the mass use cases. But now, as we are no longer technology driven, but societal and monetary benefit driven, we should really focus on those many, many use cases that really quickly scale up, and then eventually also look for the rest, which is very, very demanding and typically and also can come at quite high network deployment cost. Okay, time's up. So to summarize, in the 5G Croco project and also its sister projects, we validated 5G technologies across country borders. We have measured countless KPIs in large-scale trials, so 250-page deliverable online about this. So service continuity across country borders is possible. It's actually possible to be as seamless as it is within a country, yeah? So with service interruptions around 120 milliseconds, and this is something you won't realize in most use cases. The probability that no communication is happening in that time is actually very large. And we hope that we have set a good foundation for ongoing CEF projects, and well, we will be able to see that soon, because at least between Germany and Luxembourg, there is an ongoing CEF deployment project, which is directly leveraging on what we did in Croco. Thank you very much.
Thank you, Maciek. Without further ado, let me call Edwin Fischer. He was the technical manager of project 5G Carmen, 5G connected and automated road mobility. They were concentrating on the borders between Italy, Austria, and Germany. It was not an easy project either. Again, they were impacted as well by the COVID. So all these projects were extended around 6 to 12 months, but they all delivered. Okay, I would like to point out the number they just seen before, 120 milliseconds versus minutes of interruption time. If you can achieve this, okay, and this was achieved in the first round of projects, I think it's amazing. Edwin, that is now currently the chair of the 5G working group, or now 6GIA working group, strategic working group on deployment. So please.
Thank you, George. And just to augment that one, this is not part of the 6GIA any longer. It's now under 6G SNS, the joint undertaking. But that's it. So very good. Let me see how I can get this one. Overall presentation, 5G Carmen. Quick overview in a nutshell. Carmen stands for Connected and Automated Road Mobility in the European Union at the end. So that is Carmen. It's a bit artificial, but it's a nice name. Nevertheless, the total corridor length between Munich and Bologna would be something like 600 kilometers. Of course, we did not equip the full corridor. And what is important is like 5G Carmen did this in commercial networks. So we were augmenting commercial networks. This was not done in a bespoke, say, trial network implementation. It included 3 telco equipment vendors, 3 mobile network operators, 2 automotive OEMs, and a quite significant number of SMEs and academia representatives. We delivered 2 cross-border pilots. We spoke at the borders between Germany and Austria, near Kufstein, and between Austria and Italy at the Brenner Pass, in other words. So that was the focus. Total budget was slightly north of 80 million euros, and the duration, similar to our peer projects, was from November 2018 to July 2022. So we took 9 months of extension. Croco did it in 8 months extension. So, but that's not a KPI, not a benchmark. Here we go. What were the objectives? Implementation of a 5G cross-border corridor, as said, Germany, Austria, Italy, with a system architecture which is enabling demanding mission-critical 5G for CAM services. And I have to mention that originally, we were not only tackling, say, the maneuvering services, which are really demanding, but we also were looking at, say, collective perception. We were looking at, say, an entertainment part, which is related to, say, video entertainment when being in a kind of, let's call it, backseat position in a vehicle. But after the period one review, we refocused really on the demanding use cases. And that was really good because that was still a significant number on our plate. Nevertheless, we included some perception elements for important road safety capabilities. Also at the core was an improved and deterministic network connectivity when crossing borders. As said, we were in live networks, so in commercial networks. This is where, at that stage, we could not implement handover, as, for example, 5G Krakow did, but we implemented an accelerated network reselection. And I'll come to this in a second. So, and augmenting these, we had precise positioning and also a very early incarnation of QoS prediction. So what is the quality you can probably experience or expect as you travel along the corridor? Also important thing, we implemented as an enabler an orchestrated low latency CAM service that's running on an edge-to-edge environment, which are supported in local/regional MAC data center. MAC is mobile edge computing. So if you hear MAC or edge computing, edge cloud in that regard, that's kind of synonymous. We validated the capabilities through pilot operations in real traffic environments at the borders of a corridor. That has also some implications, I have to say. We'll come to this in a second. And then, of course, the provision of a 5G common business model, network and CCAM service simulation, and then also commissioned by DG CONNECT, a deployment study, and also our contribution to a so-called meta study, which was related to the 3 deployment studies of the 3 projects. Results. Implementation of a 5G cross-border corridor. So we delivered this full implementation in the live networks. We implemented 5G non-standalone, leveraging existing 4G radio access infrastructure by complementing it with a 5G new radio access network in the 3.x gigahertz band. 3.x gigahertz band, also known as band, what is it? 87, I guess, if I recall correctly. Or no, 78, right? That's the band. We implemented additional enablers, precise positioning, which is augmenting, say, the GNSS or navigation satellite signals by a so-called net real-time kinematic environment, which provides correction data to the signals you receive. In this case, we were relying on the GPS system, not on the Galileo system. Maybe that's something to consider in one of the next projects, to be very clear. However, these are compatible to a large degree. So QoS prediction was based on recent historic data, but what we did not implement for the time being is that we have self-learning, say, prediction algorithms. That would be something for the next stage in that regard. However, the project is over. What is important is that precise positioning really provides the required low decimeter range, which is really pivotal for mission-critical automated maneuvers, especially with vehicles in close proximity. So the closer they are, the more precise the location has to be. And under ideal open sky conditions, we were in a sub 10 centimeters space, like 8 centimeters deviation of the vehicles. It was under ideal circumstances. Sometimes it was deteriorated and obfuscated a bit by the, say, narrow valleys in the alpine area, and then it was in a range still below 1 meter, but that had an impact already on the, say, on the maneuvers and maneuverability. But the architecture supports demanding CCAM maneuvering services, which are lane change and in-lane maneuvers, and they are supported by the respective MAC nodes in the respective networks. So improved cross-border 5G connectivity and network enables, 2 key capabilities which we implemented and where we were honored by a mention by the European Commission in terms of achievement. We improved network reselection. So not handover, but one step before, which resulted in a total reconnection time of only 2 to 4 seconds compared to the tens of seconds or even minutes you could have in current networks. So when leaving the coverage of the previously serving network until selecting the new network. So that was brought down to very reliably 2 to 4 seconds. And that's really important because everything else is more or less perceived as an arbitrary network selection in the common roaming situation we have nowadays. So that's something which definitely deserves implementation in live networks. The second thing is edge computing capabilities. We've implemented these in all 3 countries in combination with local breakout, local/regional breakout. So the traffic stays within the visited country. And that is important for the low latency. You always talk to the CCAM services, between the vehicles and the CCAM services running on these MAC nodes. Nothing is going back to a so-called home network and then pinged back and forth. Low latency is really key. And with that, the communication between the device, so the modem, the user equipment, aka the vehicle basically, and the MAC services, that stays in a range of 20 to 50 milliseconds. We still have jitter, fluctuation in that regard. That comes all from the radio access network in that regard. So with advancing towards 5G standalone and more refined figures for say, maintaining aka slicing, for maintaining certain QoS parameters, this can be certainly brought down to a less jittery behavior. So more like maybe lower than 10 milliseconds of jitter overall. And that is important and does play a role. What we enabled was low latency CAM services cross-border edge to edge. That's the kind of term we used overall. That was successfully implemented for enabling these services in this distributed and orchestrated MAC or edge cloud. So it monitors, manages, and orchestrates the respective service elements across all MACs and cloud nodes. So the cross-border continuity is not only given on connectivity level, but also on service level. So instantiating the services as you travel across the border and re-establish the context. And that orchestrated edge provided or proved the support basically of decentralized in-lane and lane exchange maneuvers, and also a centralized maneuvering service, including back situation awareness, where we had an emergency vehicle approaching from the rear, having an influence in terms of deciding whether you change a lane, you stay in the lane or not. That is important. And the beauty is over just pure short-range communication, you get this information. First of all, you get it if you have short-range communication implemented. We had it in one fleet. We had short-range implemented. You get it ahead of it. So before you get the information in short range, you will get it via the distributed edge clouds in that regard. But it also provides, to some degree, even functional safety in that regard, because information is duplicated. That's important. So that was across MACs, hence we call it edge-to-edge cross borders. The validation was done by pilot operations in real traffic environments at border sections of a corridor. They were pretty extensive, as said, between Italy and Austria, or Austria and Italy in that regard, and between Austria and Germany, back and forth in that regard. These services, which we trialed, represent SAE level 3, level 4 capabilities. However, the vehicles themselves did not execute automatically these maneuvers. We would just say the actuation was still done by human drivers. That was for, say, to avoid the complexity of getting permissions and clearance for doing this in real traffic environments. One thing I would like to say and would like to mention, and that is kind of a downside. Although we said everything was working in that regard, but once you cross the border, and that was one of the questions being brought up during the final review. It's like, what is the impact when crossing the borders and you are in a, say, complex maneuvering environment and scenario? And truth to be told, if it's not complemented by short range communication, then you have a pause, basically, like the network reselection in this range of 2 to 4 seconds, plus the service reestablishment for everything. So you are in the range of roughly 10 seconds, and then driving at 100 kilometers per hour across the border during up to 10 seconds of outage, basically, you cannot perform these maneuvers. You have to pause them. So that's the kind of impact overall. And of course, since this maneuver does not only involve one vehicle, but a string of vehicles, and they are all not exactly crossing a border exactly at the same time, there might be 1 or 2 seconds in between, this adds up to the whole thing. So that is important to know. So ultimately, there is no way around having seamless handover in that regard, as demonstrated by 5G Croco, for example, but also 5G MOBIX did, right? Here we go. So almost a handover. What I also would like to mention is like the repetition of test drives in real traffic is definitely challenging. So if you want to replicate the results in a real traffic environment during the day, it's always changing, even within the same hour and stuff. You have different results all the time. So that is one of the challenges any project has to consider in real traffic environments. So either you increase the number of iterations in that regard, or you complement these by trials run or performed on test track environments, for example. So that's something as a recommendation I would give, basically. And then finally, we were looking at the business model, network and CCAM services simulation, and also providing the deployment studies. So that was based on state-of-the-art academic research. And we did not only provide these results, but also had tangible results for concrete application and implementation. So there was a new market analysis and strategy done for CCAM services that blended, say, the 5G NSI measurements we had, the NR simulations and digital twin, with a business model analysis towards a proposal for go-to-market, basically, and then the impact we aim to create in terms of, say, societal benefits. The deployment study we provided reflected the insights of the deployment studies overall, also of the peer projects, 5G Croco and 5G MOBIX. And we also contributed then to the META study, which was the kind of amalgamation of the 3 deployment projects. We also provided a proof that public co-financing schemes will be necessary in very remote/rural areas, which are not really populated in that regard. So where you have not the benefits of mutualization by other usage, basically. So, but the majority of the corridors can certainly be it can be expected that they can be covered on a financially sustainable basis and using multiple services environment, basically purely on private investment. So there's a nice complement, and that follows very much the spirit of the CEF digital program, which was developed in parallel. So very good. Quick takeaway on the midterm impact in terms of 3 years. I believe in terms of, say, cross-border network reselection, MAC deployment, that is already broadly considered in ongoing deployment projects, including CEF Digital, where we move even to seamless handover. Maciek mentioned it in the context of the 5G Deluxe, which is pretty much following the footprint of the 5G Croco project in that regard. However, also results from the 5G Carmen projects kick in there. 5G Seagull involves partners who were also involved in the 5G MOBIX environment, so even there was a kind of good blend of overall insights. The elements of a 5G for CAM deployment study and the META study are used in the ongoing evolution of a 5G strategic deployment agenda, 5G for CAM strategic deployment agenda, which is part of the 6G SNSJU. And we hope to provide then guidance in turn for any kind of 5G deployment projects along the respective national and European road transport corridors and beyond, not only road, but this conference is about road. And then we had, of course, also contributions to the specification standardization organizations, the usual suspects for GPP, ETC, ITS, ITF, 5GIA, and GSMA, in order to help evolving the European ecosystem for CAM CCAM based on common standards. And then finally, the long-term impact, and I'm already in overtime, we had identified a couple of issues in terms of misaligned TDD spectrum at the borders, for example, between Austria and Italy. And this in combination with the overall paradigm, how you can build networks at the borders basically and requiring cross-border coordination, this helps to evolve also from a, say, from a regulatory point of view. So with national regulators, we need to enhance it in order to really allow seamless cross-border coverage and implementation overall. There are a couple of measures which have been discussed, for example, with BEREC, which is the group of the European national regulators in that regard. They have not picked up the ball yet, but we are confident that will be possible in the near future. And all deliverables can be found on the 5G Carmen website. I have to say, if you trial it now, please, you can stop. There's currently an issue. There seems to be a glitch. I've informed the project coordinator, FBK, that needs to be fixed, but you can find all the material there. And also, if you would like to see a couple of, say, really hands-on videos, then you can just go on the YouTube platform and Google for and search for 5G Carmen. This is where it's a set of, I believe, 11+ videos, which exactly show what we did, including the final event, which was almost 2 hours long. So that's it for now. Thank you.
Thank you so much. Okay. Thank you. Okay. So before I forget, we found these spectacles here. So if someone lost them, those that have one on, don't worry, but please don't forget to come and pick it up. Okay. Yes. Just an anecdote, okay? We have been talking about actual trials, extensive trials with many vehicles. Not everyone can claim they did their trials with Maseratis. Okay? So let me give the floor now to Cohen from 5G Mobix. He was the coordinator, Ertik was the coordinator of this project. Very interesting project because he's the only one that was looking not only at a normal inter-EU cross-border, but also an actual hard border between the EU and a non-EU country, specifically between Greece and Turkey. This is a very important link. Again, I emphasize one of the reasons to have all these CAM projects is to increase the efficiency. Just that border, there is much more than 100 million euros of goods per day. So if you can increase the efficiency of this border crossing, you have a tremendous impact, a tremendous economic impact. So let's not forget this. And with this, I give the floor to Cohen, please.
Thanks. Is this yours? So Mobix, indeed. I'll dive into the Greek-Turkish corridor a little bit more, but it's not only the 100 million goods that are going around, it's also sometimes truck drivers are stuck in a traffic jam for over 2 days, while your family's like 5 kilometers away. But if you try to cross the border walking or swimming, you'll probably get shot, so don't do that. Overall, I want to start with the consortium. It's huge. 59 partners from the EU and 11 from outside of the EU. But what you see here, and actually there's a reason to do that, because you want to deploy this widely. That means that everybody should more or less be on the same page and should know what kind of directions you should take to ensure that in the end you can scale up and deploy it and your car still drives over the road. So, but if you look at it, we range from business, like the Nokias and the Ericssons, the vendors and the telecom operators like the KPNs and the Cosmotes, Nosh. In the business side, we also have placed the public authorities like Noord-Literaal, for example. All the way to R&D, where we have universities and institutes like ICCS, TUB and CTAC. And we also run from automated driving. For example, Ford Otosan or KTEG towards telecom and connectivity, and then you get into infrastructure, yeah, indeed, to catapults, etc., and the Siemenses. We have over 24 million in costs and a contribution of over 20 million. Thank you for that, Jorge. In total, we have 8 sites, 2 CBCs, 4 national sites, and 2 Asian sites, and I'll dive into that a little bit deeper as well later. There was one overarching objective, but don't read it because this is just plainly from the proposal. What I want to say to you is, Jorge already mentioned it, CCAM will not happen if we do not fix the cross-border corridor. There were some examples as well, but if you look at this use case of automated driving, a long-haul truck, if this long-haul truck, especially if it has valuable goods in it, if you cannot reach it each and every time throughout your corridor, there will be no one who will use it. So if you want to enable this cross-border mobility, especially for the long-haul transportation, where there's a driver shortage as well, and they can only drive 8 hours a day, this needs to be solved. So the whole point is, solve this. That's the overarching objective. And not only from a technical point of view, also business, what do we need to do in policies, etc. So there are these project objectives that nicely fit in the work packages that are just a number. In the end, it's about definition. What are we going to do? What are we going to show? And how are we going to prove it? That's done in work package 2, so requirements. Create the borders, of course. Build it, deploy it. It's done in work package 3. After that, we analyze what happens. If we have that knowledge, if we have it available, trial it. And the trials are actually a key part of the project because it feeds into recommendations on standardization, on business opportunities, and it helps to spread the news of what we are doing. So let's dive into the results. Actually, the results you can summarize in one key message, which is 5G delivers a capable solution that you can use now, and it has room for growth. So, the capable solution. What we managed to do was deploy 2 cross-border corridors, one in Spain, which is actually 2 cross-border corridors because we have a highway, and we have a very old bridge, which is a challenge on its own because it's a cage of Faraday. So no way that you have a telecom reception in there, so that needed to be solved. Plus, all these gantries on the side, you cannot see what comes from the left or comes from the right if you're exiting the bridge. And it's a 1-lane only road of some 200 meters. So if you enter the bridge at a certain point and you get a traffic from the other side, you might have an issue. So that was a very challenging one. And we have the cross-border corridor in Greece, Turkey, indeed, what Jorge mentioned. That had also very interesting challenges because if you want to do some spectral coverage measurements, you need to be in no man's land. And the only way to be in no man's land is by an armed escort. So that was also a very interesting exercise there. In these cross-border corridors, you cannot test everything, as Edwin nicely said. You need to accomplish it, complement it with other sites. So we had 4 national sites in the Netherlands, in Germany, in France, and in Finland, where we trialed things that we could not do in that cross-border context alone. Of course, a lot of these solutions in the end were tested in the cross-border solutions on the road as well. But you cannot play that much around in actual deployed commercial networks. We also had 2 Asian sites focusing on, for example, millimeter wave. Around 100 sessions and 170 test cases we performed using this technology, and combined it was we had some 29 5G G-Node Bs. I still hate the word. We started off with an NSA architecture and ended with an SA architecture. In total, we had some 20 SAE, actually 21, if you add the level 5 shuttle vehicles. And we used the 5 use case categories of 3GPP. So, for example, advanced driving had a lane merge use case. Vehicles platooning had a platooning use case, of course. Extended sensors would be the pedestrian that comes into view directly in front of your car. Remote driving was actually remote driving and teleoperation, which are slightly different. And the vehicle quality of service support, for example, predictive quality of services that we used. So the capable solution has shown that seamless cross-border mobility is feasible. We had a best service disruption of 0.2 seconds, which was a nice one as well. And the throughput, 900 versus 130, of course, with 5G or actually every telecom operator, the throughputs are not symmetrical because usually videos take more to download and less than to request the video itself. We have received the best round-trip delay of 10 milliseconds. We intentionally stated differently as latency because latency is, what are you measuring? Are you from windshield to windshield or not? So the best round-trip delay was 10 milliseconds, which basically is a ping. And we had a cross-site deployment of 6 solutions, so from Finland to Spain, etc. In total, we have defined 11 cross-border issues, which range from no coverage or no interaction between operators. And we had 21 considered solutions trying to find or solve these cross-border issues. So we deployed 9 types of 5G technology for NSA, it should be, which was commercially available, which is very relevant to know, and SA, so these 2 are wrong. Including 5G V2X and PC5 side link. In total, 14 commercial and 2 research networks, so to be able to complement what we do on the road with research, to have more flexibility. Plus, what happens is that you can have repetitive tests easier, so that you can get into statistical meaningful results. So 29 G0Bs, 24 MAC edge nodes, 22 roadside units, 32 OBUs in 21 up to level 5 vehicles. We found the best balance between latency and service disruption by using the SN handover with the S10 interface along with home routing in NSA option 3X. I'm not going to explain that. We have a lot of results there that do that, but for very low latency services, we need SSC mode 3, which was not available. One thing to know here is that if you do an MNO handover, it's a cooperation between 2 organizations, and in October we had a workshop for the 5G corridors projects in which a person has calculated there are some 240 border crossings, which means that if you have this inter-PLM handover, you have a scalability issue, which has not been solved yet, but it has been marked as a recommendation to figure this out, because otherwise it's very hard to come to a solution that is usable everywhere. I don't know how that happened. So, you can use it now. We did that in 100 trial sessions with around 170 different test cases, which gave us a lot of knowledge. It was in the CBCs, but also in the national side. What we also did here is, for the deployment study that was mentioned, we did some assessment for other corridors that I'll jump in a little bit later as well. The multimodem and multi-SIM solutions may help with performance if you support link aggregation. If you don't, then it's harder to get the performance that you want. Notable is the impact of application level protocol designs, with which we mean you need to cooperate. Application providers very often just use the as-is connectivity options that operators offer. But for CCAM, you need specifics. That means that you need to collaborate specifically with an operator to create your application, basically, because there are options in the network that operators offer. Use them. They must incorporate session re-establishment, because if you have a very short session interruption of 0.2 seconds, if your application cannot cope with that, you're in the fog anyway. Now, slicing benefits the quality of service if stability of the terminals improves. What we noticed is that with slicing we could have a very good effect or a very good control of the quality of service, but the terminals that we were used sometimes crashed. Well, that's not an option. If you want to have quality of service, then your terminal must be reliable. But that was not available at that point in time. It has room for growth. What we noticed is that the user acceptance for 5G for CAM relies on trust. To put it shortly, it is better if your service fails than when it fails unpredictably. If you drive a car and suddenly you need to do something, your trust in the system goes down. So if you have predictive QoS, you can say in advance, please note, we will have some issues in the near future, take over. But if you suddenly need to take over, you will not use the system anymore. So this trust is actually very key. Knowledge and learnings of the equipment that we did in the trials resulted in 10 standardization contributions and a lot of other recommendations. But we also identified an emerging market. So the major cost driver from the deployment study, what we did is geography. Alongside the trial sites that we had, we also investigated the Finland-Norway crossing and Netherlands-Germany border crossing. And what we noticed in this study, by the way, done by Datacom, Roman, thank you for that. What we noticed is that the major cost driver is geography. So, for example, in Norway, Finland, it's mountains. Try to find a tower there and try to dig a fiber there. It's massively costly. Whereas the major benefit driver was the traffic volume. So that means that you can identify the border crossings that are useful to start with. We investigated 10 business models and 9 customer groups. One of the business models that was very interesting was actually the long-haul truck. If you calculate it, it's actually a no-brainer to do it. Which gets us to the mid to long-term expected impacts of the project. The learnings of the combined projects of the ICT 18 call are progressed in the CEF Digital 5G corridors, but also in other projects like 5G Blueprint and the ones that Edwin mentioned. This is supported by the GUIDE project, so if you want to know more about these corridors that are being deployed, scan the QR code. Currently we have 8 studies and 7 works, which will jump a bit because the new round of calls is almost signed. And the goal is to network and capture the best practices, develop a project pipeline and coordinate the development of the 5G SDA. And the usage. There was a projected fleet availability of level 3 plus vehicles, also from the deployment study we did. This will help you to identify the moment in which your use case might become positive, basically. For the vehicle operations, the main beneficial one was speed and vehicle to anything interactions. Driving quality, the hard braking reduction was a very useful use case as well. And in the end, the quality of travel, so the reliability of your trip was also a very relevant output that we got from the surveys. Thank you.
So I'll give now the floor to Hamid, who will conduct the question.
Yes, sure. I will try. This gives us 5 minutes. Live. Do you hear me? Does it work?
Did you turn on?
I don't know. Oh yes. Now it works. It gives us 5 minutes. We just go straight to the questions you might have. Everything clear? Yes, please. Going. We have to run.
Can I take the microphone or? Okay.
This time you can.
This is the one that I can take. Okay.
Yeah.
So I'm Diego from R&D at Autostrade per l'Italia Group, Italy. I have actually 2 questions, but they are very, very fast. So first of all, in all the projects that you shown us today, do you ever consider also deploying of private 5G network managed by the road operator, for example, and which service, mobility service dedicated? This is the first one. The second one is related to 5G Carmen project and the precise positioning topic. Because, for example, considering all the kilometer of tunnels that we have in Europe, in Italy we have half of them. So positioning is for sure a problem. And I don't know if you ever consider other kind of positioning system beside GPS or RTK connection.
Thank you. Who wants to answer? Yes.
Shall I take the first one? No, we did not consider private networks. Basically because, actually yes and no, because a research network is a private network. But if you want to do CCAM, in the end, it's very hard to have a private network spanning Europe. You have a lot of operators, you have a lot of road operators, they all have their preferences. And if you want to try to create a singular private network there, that's not going to happen. So no, we did not look into that, but for specific locations, it might be useful. Because, for example, a tunnel, if you have a tunnel, you do not want to have 10 operators mounting their...
But that's something different.
Yeah, that's something different indeed. But if you have your infrastructure and you rent it, for example, to operators, then that's a different ballgame.
Yeah. Would you like to add some?
Well, just complementing on that one is, if you deploy a bespoke network, which would be like, let's call it a 5G for CAM or 5G for CCAM network, you kill all the mutualization benefits, basically. In other words, that would require a CEF digital program on steroids in terms of money needed in order to deploy a bespoke network layer, apart from the fact that, say, what is the amount of spectrum you need? The inefficiencies, if you start dividing networks into more subframes, basically, then it simply becomes totally unrealistic. That's really an issue. It's a bit like you would go in the rail sector with FRMCS being deployed in bespoke spectrum. That is fine because the rail sector is pretty much, let's call it deterministic overall. There's a number of tracks, a number of trains, and that's it. But even there, they already know that sometimes the capacity might not be enough and they might need public networks to support, say, FRMCS type services. And that's why just the economics wouldn't work. That's the issue.
Yeah. Can I add something? Sure. Another aspect of these private networks is that, unfortunately, not all countries have allowed private networks. Okay, they exist in Germany, but in most of the other European countries, they are not available. So this is not a pan-European solution.
Not a pan-European solution. Satisfied? The first part. And the second part?
Exactly,
yes.
Yeah, that was the second part of the question. I grabbed that one. So we have trialed GNSS RTK. And my personal opinion is I wouldn't see anything else. So we still have the tunnels to solve, and there, to the best of our understanding currently, fake satellite solutions, leaky lines that can go into the tunnel appear to be the best choice. I'm not sure if, so during the Croco project, we did something very stupid. We managed to have 5G into the tunnel, which we have in Luxembourg, but all our result collection systems rely on GPS, and our applications didn't work, so we didn't trial in the tunnel. But, and there particularly what we did, so there is tons of RTK solutions out there. Any internet connection can provide you RTK data. Many of those solutions claim to be open, but they often have in common that you end up with a vendor lock-in, or switching your vendor for an automotive company becomes very cumbersome. So 3GPP, mostly being known as a telco association, also in the past came then up with a standardized way of delivering RTK data, which hopefully has then enough industry support behind it. So this is what we were trialing in the Croco project.
Thank you. So we need this industry support very much. We have to, otherwise it won't work. It means that we don't have time now. But I just send you a question. Do you remember the time when we didn't have this much of connectivity? How many remembers? I'm the oldest one here. You remember, Tom? Good. We are in the same age. You know, there was a time actually connectivity was not an issue. At that time, people didn't know about each other this much that we do today. It has benefited us. This connectivity has become a benefit. And as much as I cannot actually remember when we didn't have connectivity, I cannot imagine a world without 5, 6, 7G, things like that. We are looking forward to that future. Thank you so much. Big applause to everybody.